Hey guys, this is your instructor Daniel Martinez with the Civil 2275 class, talking to you today about how to take this midterm project through to the finish line. As you can see, I'm going to try to keep this video as short as possible. So I'm going to pump out two videos. One is going to show you how I'm going to take this project through to the finish line. The other one is going to show you how to plot it to meet the requirements set forth in the PDF of design criteria on the second sheet. I won't be going through everything. I am going to more guide you guys on how to actually get the sheet set up to be able to plot it. So to jump right into it, I'm going to give you guys a warning as well. I am a little under the weather, so please forgive or excuse any coughing or throat clearing that I might have to get into. So as far as taking this project through, what I have here is, I think, the last thing that I had shown you guys in class, or that we had discussed. A lot of the class should probably have corridors. Hopefully everybody has this assignment complete, and this is just going to be a little review for everybody. Otherwise, I am going to take this assignment through with where I left off, which is I need to create my corridor and actually get my road in there. As you can see, my pad's already graded in. I do have the berms graded. I'm going to select my pad surface, right click and put it in object viewer, and I'm going to see that my pad doesn't have any holes in the middle. It does have a berm that meets the project requirements for secondary containment. So that's good. So now I'm on to the next portion. So the next step is I have my alignment in there, and I think I pretty well like where my alignment is. We have this right triangle here that we made. This triangle has sides of 200 feet and 40 feet, I believe. Yeah. This gives us an angle of 20% grade. And what that allows us to do is we can take this triangle, if you guys remember, and we can compare this to the surface that we have that's a route depending on where we are on the alignment that we created, and we're just going to confirm that all these angles are less than 20 degrees. Or, I'm sorry, 20% grade. Especially important here at the pad. It sees that we're probably going to end up being at about 12-13% grade creeping up the pad, and then we'll have to create a little mountable berm here. It's going to be a little bit different because we're going to be skewed pretty heavily. So to summarize my alignment, I like the way my alignment's looking. I'm more or less along the center line of what appears to be some existing roads out there. It looks like my percent grades are all going to be below 20, which is great. If you remember from our project specifications, the maximum gradient allowable on this project is a 20% grade. The recommended, or the ideal, is 15% grade here on the bottom right. So I think we're going to be able to accomplish that pretty easily. So my alignment's set. I also like my radiuses. That was another criteria. Let's see. So here we go. The proposed alignment shall have a minimum radius of 100 feet for each curve. So what I have done is I have gone through my alignment, and I have actually stretched my curves out to make them greater than 100 feet to just make it a little bit more manageable to get up. So if I want to check my radiuses, I'm going to select my alignment, and I'm going to go to geometry editor up here. This is going to bring up that box where we can delete PIs, and we can add new PIs and so forth. One handy function of this box is this button on the far right, which is going to bring up a table showing or summarizing all the radiuses that we have on this project. If this was a real deal conceptual, I would probably make these nice even numbers and make that 180. This would be 320. That'd probably just be 1700. But don't really matter. It doesn't really matter for this. So at this point, I like my road pretty well. My profile looks good. I'm going to move on to the next step. The next step in road design, which is in Civil 3D, we have the four basic entities that make up a road. We have our alignment, which is set. We have our profile, which the profile is created, but we don't have our design profile drawn up yet. So that's actually a good reminder. I need to go ahead and draw up my profile of what the road's going to look like. So I might make this one long video, but then in the description below, yeah, actually check the description below now. I'm going to have, this is going to be one long video, but I'll have timestamps for what each portion is covering in the description below. So feel free to open up the description and click through to the appropriate timestamp for what you're getting into. What we're talking about now is profile creation. Our alignment's already set. So to create a profile, I think I got everybody up to class where they actually have a profile view or profile graph created to draw on this graph with a profile. We're going to go to Profile and then Profile Creation Tools. And I'm going to kind of go through this a little bit fast, guys. Feel free to watch this at half speed, watch this at double speed, or whatever you guys need to, rewind and whatnot. So once I hit that button, it gives me this little pick box. I'm going to pick over top of my profile, and it's going to come up with this dialog, Create Profile. I'm going to name this Proposed Road Profile. Style is good, label set is good, so I'm going to go ahead and hit OK. This brings up another one of these little dialog boxes. So, generally speaking, we work from left to right on these dialog boxes. I am going to go ahead and draw a tangent without curves. If you remember, we do have options to draw it with curves. For now, I'm going to draw a tangent, no curves, and we'll add them in manually. So, good rule of thumb is my alignment is starting kind of in the center line of whatever this road was. This road had some odd name to it, but my center line is starting at the middle of the road. So if I go to my profile and I do something like this, where I snap to the beginning and then I just start moving up, what's going to happen is in the center of the road, right where the little yellow double lines are, whatever, of this road that we're intersecting with, you're going to have a hump in the middle from where traffic is supposedly supposed to have a little speed bump to get up and around this bend. So it's generally not a good idea to start going up immediately from your crown, essentially, of your road, your center line of the road. It's a good idea. You can kind of even see that this road is flat for a ways. This is probably about 10 feet. It is a good idea to kind of follow the existing cross slope of your road, if you can see that, before you take off. This will allow you to have a nice smooth transition. So I'm going to draw myself a little line and be a little bit extra generous with how much room I give this profile so that I can fit a curve in. And then I'm going to draw very few vertexes in this curve. The more vertexes we draw, the harder it's going to be for you guys. So even though this looks really bad right here, I'm going to fix it all later. I'm just going to get a rough idea in now. Let's see if I can get away with something like this. I'm going to try to make that match the existing ground. So I think I'm actually going to snap this profile to my berm top and then grade it out. From previous lectures, I've talked about mountable berms. You shouldn't have an approach slope greater than 12% or a descending slope greater than 12%, I believe. Since our approach slope is greater than 12%, but our departure slope is much less than 12%, I think this is acceptable. All right, so now I've got a profile. It's obviously pretty blocky. So what I'm going to do now is I'm going to start adding curves to this profile. If you'll remember from our specifications PDF, the proposed road alignment shall have the minimum radius and profile shall have minimum K values of 12 on vertical curves. So with that in mind, with this toolbar open, and if you accidentally close out of this toolbar, it's really easy to get back into. If you select the alignment and then just hit Geometry Editor, it'll pop back up. So with a minimum K of 12 in mind, I'm going to hit this button, which is to enter curves into a profile. I'm going to select the free vertical curve parabola option. I'm going to zoom in. I'm just going to follow my prompts here on the bottom left. Select first entity, that's our tangent in. Select next entity, that's our tangent out. And then it asked me to enter a K value here. I'm going to enter a value of 12 and hope it works. So no solution available with 12. That means that a radius of curvature of 12 is, I'm sorry, a K value of 12 is not going to fit in this area. So I need to make some adjustments here. I think probably what I'm going to do is just raise grade here a little bit. Try again. What will work? Ooh, this guy's going to be tough. All right, so it's really let me have a hard time with that K value. So what I'm going to do is I'm going to flatten this slope out a little bit. I'm going to work on my next grade and try to flatten that out. See if that helps any. Wowzers. Okay. All right, so another thing that's acceptable, because I'm going to have a hard time fitting a K of 12 here, another thing that's acceptable is to just have a grade break in your profile when you depart from the existing road. So with this button, I'm going to add myself a little grade break, just so it's following the existing road slope for a ways until it hits like the edge of the road, and then that's where it starts ascending. So I'm going to go in here. I'm going to see if I can fit a K of 12 now, which it looks like it worked. Yeah, there we go. Start fitting. So I'm just going to run up this road and add these values, these curve values in. So this one I'm having that issue again. What I'm going to do to resolve it is try to smooth my grades out as best as I can. That's all right. So I'm going to add all these curves in, and then I'm going to see what my profile looks and see how I can fix or make it fit a little bit better. One more. All right. So I have all these in here. All these labels are kind of tough to read, so I'm going to crank up my drawing scale to 1 to 20 just to give myself something to look at. All right, so let's see what we have. So that's pretty good. This curve could use some work. So basically what this is telling us is the trucks that are coming in, they can't, this curve is too sharp here. If we were to follow the existing ground, the trucks would bottom out in that location. So likewise in this area, this curve is too sharp and the long tractor trailers would bottom out here. So what this is saying is that we need to smooth out this existing area, cut through the peak there a little bit in order to fit our trucks in. Here I have a big fill right in this area, so I'm going to even this out a little bit. Alright, so that works. 12% up, that's good. Very nice. Alright, so our preliminary profile is set. that will be the end of the profile section. If you guys need to follow along, I'm typing the commands in on the right, whenever I do a command, you'll see it pop up here on the lower left side if you don't know what I'm doing. So save, very important for this project because there's going to be a lot of stuff going on at once. So now we need to generate the third entity in road creation in Civil 3D, which is the assemblies. And if you remember, the assemblies is like the typical sections for what our road is going to look like. Now in our specifications here, we kind of have a half of a typical section, half of an assembly. This is defining a generic area of how our road is going to look. So just to read through the specs here. The proposed road shall have grading side slopes as specified in Item 1. Item 1 refers to side slopes for all entities are highly desired to be no steeper than 2:1 in cut and 3:1 in fill if possible. We're going to try to do it 2:1 cut, 3:1 fill. I think we're going to have to do 2:1 cut and fill across the board though. Let's see. The proposed road shall have 2 lanes of travel, 10 feet wide with a 2% cross slope down and away from the crown, which is what's showing. And then we're going to try to mimic a ditch in cut situations and then a fill surface in fill situations. So in order to do this, we need to create an assembly. And just like we've been doing for everything else, that option to create an intelligent Civil 3D object is going to be in this location here, assembly. Hit create assembly. I'll run you through some prompts here. I'm going to call this, I guess click in there, road. Man, I'm a terrible typer. Typical section. And then just drop it in somewhere. It should zoom into it once you left click. At this point, we're going to start to add entities to this assembly now. So if you guys remember, the way we add entities is we'll build one half of the assembly, which is generally the right, and then we'll mirror that half to the other side. So in order to add sub-assemblies to this assembly, and I apologize, I'm used to using sub-assembly and assembly interchangeably. The assembly is this green marker. The sub-assembly is the items we add to it. So those sub-assemblies can be found in tool palettes up here on your home tab. So if you scroll along, you're going to go to basic, and this is in line with what we've been doing with the other projects. So basic lane transition. That's going to be our lane. So click here on the right side of your circle. Alright, so there's our lane. Now we're going to add a basic side slope cut ditch, and this is going to define how we grade this lane into the existing ground. So I'm going to add that link here on the top right corner of this assembly. And we can close out of that window. So I have half my road drawn already. Before I mirror it, I'm going to change the specs of this road. If you'll remember, we need to have a 10-foot wide lane width. If I measure this road right now, it is going to be at 12 feet wide, so we need to change that. To change that, select your lane and go to your properties. Scroll down a little bit till you get to your default width. Change that to 10. The depth is of no concern at this point. The default slope, as defined in the specs, is supposed to be -2, so that is fine. What you should not see is, especially when you mirror it, you should not see a 2 and have it going up from the center line. It needs to be -2 going down and away. So we have a 10-foot road now. Now we need to define our slopes, our grading slopes, which is what this thing is. So if we select this cut slope layout mode deal, scroll down through our properties, we're going to see a bunch of options that we have here. We don't care about anything below back slope width. All this stuff is inconsequential to us. That's for more advanced functions. So the ditch criteria that we're going to set forth is we're going to have a 2-to-1 slope going in or down for 2 feet, and then a flat bottom for 1 foot before we grade back up to existing ground at 2-to-1. So our cut slope here is 2-to-1, which is good. Our fill slope, we're going to try to do 3-to-1 based on the specs. Force slope is in reference to this first I believe it's in reference to this first downhill away from your lane. So force slope is going to be another 2 to 1. Force slope width is going to be 2. Bottom width is defining the width of the flat portion of our ditch, which we said was 1. And then backslope width or backslope slope doesn't matter because we don't need to have a set back slope that's different from our 2 to 1 cut because we want that all to be the same. So just here under back slope width, I'm going to set that to 0, and then it won't even show up. So long as you have all these options set, and this might change later, we might have to change this fill slope from 3 to 1 to 2 to 1. But for now, we're going to give this a shot and see if we can hit the ideal conditions. So at this point, this assembly is good to go. This assembly on the right side is good to go. I'm going to highlight both of these options, and then not using your regular mirror command. You have to use a mirror command that shows up in your contextual ribbon up here to mirror subassemblies. So I'm going to click on the center point, and it'll mirror them back to that location. And at that point, this is our road typical section. I like it. So I'm going to save, and that concludes the assembly portion. That's pretty easy. So the next and last step in generating a road design in Civil 3D is we need to generate our corridor now. But finally, we have all the data available to us, being our alignment, our profile, and our typical section, that we need to run the corridor for the corridor to be able to function. So to work with our corridor, notice I just saved it. I'm going to go to my Home tab, select Corridor, and then from that drop down I'm going to select Corridor again. This is going to run us through the window we've seen many times. I'm going to name this Proposed Access Road. Let's see. So we're going to ensure that alignment and profile is selected, which it should by default. The alignment should be your access road. Oops. The profile is not existing ground. It is going to be our proposed road profile that we just drew. That's this one that has all the curve values in it. The assembly is going to be the one that we just created, which should be the only one in your drawing. If it's not, ensure that you have the proper one selected. Then lastly, our target surface is going to be existing ground west. Now I'm going to give you a little tip. I'm going to do this to show you guys what happens when you select existing ground west. We're going to need to generate a composite surface because what happens when we get to this area is that the access road is going to grade down to existing ground instead of our pad. So it's going to especially become an issue when we get to our mountable berm because it's going to really blow up our fill numbers. But just for the sake of demonstration, we're going to add just the existing ground. So hit OK. Just because we are proactive engineers, we're going to go ahead and change our frequencies to make this a little bit more useful. Go ahead and select everything at 5 feet increments. And change all these yeses to nos. And what that is doing is it's telling CAD that we want to add a link or we want to add a sample, a typical section of this road every 5 feet, and we do not want to add an additional supplemental section every time we cross one of these features, whether it be a vertical geometry point or cross a triangle in existing ground. So hit OK and rebuild. And I'm actually surprised that worked. So this looks pretty good. So in this area, I'll show you what happens here. So before we get much further, it's going to be easier to show you guys what's going on if I create a surface out of this corridor, which we're going to need to do anyway. So to create a surface on the corridor, select the corridor, hit Corridor Surfaces here, or go to your Corridor Properties tab, and go to your Surface tab. In this screen, you're going to select the left button, which is Create a New Surface from the corridor. And then you're going to add, so this is just an empty placeholder at this point. You're going to add data to it, which is just the top of your assembly. It's going to sample the top portion of your assembly. And then your surface style, I'm going to go ahead and change it to P contours 2 and 10, just so we can actually see it. Before we add this, before we select OK, we also need to go to the Boundaries tab and add the corridor extents as an outer boundary so it doesn't triangulate everywhere. And we will see that regardless of what we did, it's still triangulating. So as long as you did all these steps correctly, you may or may not have this issue. The reason I am having this issue is because, as we've discussed in class, I've got a bow tie in my corridor right here. What that's indicative of is that I have a radius, or a turn, that is tight enough that my corridor links overlap themselves, and you can actually see that happening right here. They overlap themselves, and when that happens, Civil 3D freaks out and doesn't know what to do with the data. So in order to even that out, one, it's not going to be a problem once we set this surface targets up correctly, but two, just to get rid of it for now, I'm going to just widen my curve out, touch, and hopefully that fixes it. When I do that, I'm going to select my corridor and rebuild it. And that fixes it. Also, we have a waterfall. I didn't know that was part of this project. Yeah, that looks really funky. So in order to fix this, what's going on is that this road has profile data all going up through here until it gets to this point. If you'll remember, this is going to be the end of our mountable berm. You can actually see in our profile, that's our mountable berm is in this location, the tip of the berm. So what happens is I stop my profile short and I didn't give it any data. So what it's doing is grading down to 0 elevation down here. So I can fix that two ways. I can either drag my I guess we're not actually snapping to existing ground here, which is not part of the issue, but just a good habit to get into. Now I can either stretch my road profile out to the end, which I'd probably not recommend doing, or I can just take my corridor and drag it back. If I select my corridor and hit this little green grip, I can drag it back to a point where my lane data freaks out. And I believe I'm going to drag it back to here and see what happens. This will be a little bit of trial and error. So that takes care of that. So if we pick this up in Object Viewer, along with our proposed pad, we're going to see from the top, this actually looks pretty dang good, right? Contours are tying in nicely. Seems like the road's even doing a good job of grading through. I do think we will have to fix a little something that happened to the profile when we stretched this radius out. But for now, this looks pretty good. However, there's an issue. If I actually look at this upside down, or from the bottom, we'll see that my road is actually doing a lot of grading in through here, and that my road volumes, this road fill, it's counting all this area underneath itself. Oops. All this area underneath itself is fill. So it's not actually grading to the existing ground, into the proposed pad, even though it looks like it from the top. It's just cutting right through it. So we're going to get rid of that issue. I'm going to save this first. So as proof, I'm going to also do a volume report on this road. So to do a volume report, a couple different ways. The easy way is to type in report, surface, and volume should come up. Otherwise, you might have to spell the whole thing. Report surface volume. Oops, there we go. Hit this top left button. Make EG, or existing ground, your base surface. Ooh, hold on. We can't do this yet because we need to make that composite surface. We can still do this actually. So I'm going to make existing ground west my base surface and proposed access road here, the corridor surface, as my proposed. Give it a second to do the calculation. And we'll see that we're sitting at, man, that is so much. Almost 25,000 yards of fill to make a net cut fill quantity of 22,000 yards of excess quantity, excess dirt that they're going to have to haul away from the site. That's a big deal. We can't have that. However, in this case, this is fake because it's adding all of this fill material into the road, which is not accurate. So I am going to take a little screenshot of these cut fill quantities to show you kind of a before and after. So now what I'm going to do is I'm going to correct this targeting. So I'm going to make another composite surface here that has the data blended in from the pad and the existing ground. So to do that, we need to create a new surface here by right-clicking it and hitting Create Surface. Tin surface is fine for this. I like to call these composite surfaces, I like to describe them by what they are. So I do EG-pad-composite. And then I am actually going to put this, it'll be on no display eventually, but just for the sake of showing you what actually happens, I'm going to give it a display. Now we just created an empty placeholder. There's not actually any data in it yet. Please ignore this on the not for use. Do not address that exclamation point. So we're going to expand the properties in tool space of this pad. And if you don't have tool space, you can either go to the home tab and hit that button, or you can type it in. We're gonna, oops, not that one. We're gonna expand the definitions here, and under edits, we're gonna right click that and hit paste surface. We're going to paste both existing ground and the proposed pad. We're gonna do them one at a time, existing ground first. This is very important that you do this in the correct order. You paste existing ground first, and then you paste the proposed pad second. You see my contours got all dark here. So if I were to pick this composite surface up, this is what CAD now sees as a grading model for the road. It sees one continuous surface. There is no cutting through other surfaces. This is basically a representation of what your finished ground is going to look like after they build the berm. So now that we have that, I'm going to go ahead and put this on a no display layer just to not clutter up my drawing. That was done in the surface properties. So now that I have that data, I'm going to go to my corridor, and I can do this by either selecting my corridor or coming down here and expanding corridors. I'm going to right click it and open up its properties. These are the same properties we've been working with. Under parameters here, I'm going to hit set all targets. And what I'm going to do is I'm going to change the surface that it's targeting to, and I'm going to make it the composite we just made. So you can see in the surfaces tab here, both options are set to the composite. So I'm going to hit OK a bunch of times and rebuild. Ooh, wow, look at all that grading stuff that just disappeared. So now when I pick up the pad in the road, still look pretty much the same from the top. However, from the bottom, they are no longer cutting across each other. They're playing together pretty well. So now, when I do my surface report, I add my base as my composite, and then my corridor as my proposed. If you remember, we had an excess fill situation at 22,000 yards. Now, we are pretty much balanced. Look at that. I don't really have to do much work on this. We have an adjusted cut and fill value that equals out to a net cut of 32 cubic yards, which is really small. That's really fantastic. So what that means is that the contractor has to dispose of 32 cubic yards of soil on site, which is much better than needing soil to deliver to the site. So one thing that I am not a big fan of here is we actually have a pretty tremendous cut slope here. So what I'm going to do, so if you guys can kind of see what's going on, maybe if I strike a cross section across here, you guys can see a little bit better. So I'm going to draw a polyline, right click that polyline and do quick profile. I'm going to add my composite surface and my, let's see, corridor surface, just so you guys can see what's going on. So what's going on is this is my proposed surface. My access road is actually cutting into my proposed surface. And we can't have that. It's really drastically reducing everything on the pad. So what I'm going to do is pull my alignment away from the road a good ways until it is filling over top of all that. You can actually see this is proof that our ditch worked well. Going back to the assemblies. So in order to do this, I'm going to save first because this could potentially make CAD mad. So what I'm going to do is I'm just going to actually grab this and push it over a little bit. Rebuild it and see if I moved it enough. Looks like it. I like it. I will need to adjust my profile ever so slightly. Ooh, that is really high, yeah. I'm going to need to put these back. Snap them back to to the berm. I'm going to try to not drape this perfectly on existing ground. On the pad, I'm going to try to give it some room to move. Because if I were to lay that profile line right on the pad again, I'd be right back where we started as far as cutting into the pad. So I'm going to try to edit it like that. I'm going to try to push these back a little bit. Yeah, there we go. All right, let's see how she fits. Ooh, looks like it's cutting again, so I'm going to raise that profile a little bit more. Very nice. This portion here, it is cutting slightly, but I'm not too worried about that. This is something that if we were really getting into the details, we would fix all this by hand. But you know, we're just trying to produce a conceptual out, so that is good enough. What's important is that if I go back to my little quick profile here, I'm just going to leave them all in there. You can see that my road is now skimming the edge of that berm, so that's good. So I think this road looks pretty good at this point. My volumes work out pretty well for the road. There's not going to be much excess excavation from the road that are going to be in there. Let's go ahead and review our document and make sure we're within spec. So the road stuff kind of starts in this area. So ditches shall be added to the road in cut situations. We've done that. Our cross slope, our typical section for the road looks like that, so that's good. Road's going to have 2 lanes of travel. Got it. My profile grades I think are 15 or less, so that's good. Attacking item 7. The proposed road alignment, we're all good there. So guys, I think that pretty much covers what we're trying to do. I'm going to look through my profile real quick to make sure everything's on the up and up. Yeah, that's not bad. Start to get a little filly here, but I think that's all right with what we're doing. Yeah. So that pretty much concludes the video, guys. One last thing I'm gonna do is I'm gonna turn this all into one composite final grade surface, so that for the purpose of plan set preparation, we won't see all these little intermediate entities. So what I'm going to do is I'm gonna go ahead and turn off my pad to no display. I'm also going to turn off my corridor. surface and make it no display. Oops. Alright, so there should be no surfaces shown on this drawing. I'm going to go to tool space. I'm going to make another composite surface, but this one's going to be different. This one is going to be a composite of all of my grading features. So this is going to be kind of like a final surface, so I'm going to call it final grade. I'm also going to change the style to P contours 2 and 10. And then I'm going to add, in my tool space here, I'm going to add the data from the pad first, because we're building these from the ground up, and from the road. Now when I pick this surface up, this is one nice continuous surface that really conveys what we're trying to, the message we're trying to get across to the client. Me being your client. So if I was getting really nitpicky with this, you would 100% have to add a ditch in between the road and the pad here. So right now, what's going to happen is water is going to run along down this hill slope. It's going to hit the edge of the road, and it's just going to travel down it and probably cause erosion. So what I'm going to do, once again, I'm going to try to give myself a little bit more room with my pad to give myself a little bit more of a ditch if possible. Oops. Kind of throwing a curveball here at you guys at the last minute. Trying to think how I want to add it. There we go. So we see we have a little bit more of a defined ditch going through here. Lastly, I'll need to rebuild my final grade surface. And now we have a nice ditch. So if we were to do that water surface analysis, water drop analysis, you would see what happens. A little raindrop falls right here on the outside edge of our berm, comes down to the road, and it shoots on down that little ditch, which is fantastic. It's exactly what we want to happen. Likewise, if a raindrop falls here on this crown slope, what it's going to do on the left side of our lane, it's going to hit the ground, hit the access road, fall down the crown a little bit till it enters the ditch in this location, and then it's going to travel all the way down. It's this little white line. All the way down until it gets flat to where it'll pond. I'll show you how to take care of that in the second half of this semester. So that covers it, guys. Thanks for watching. Next video, we're going to talk about how to create the plans to show what's going on here.